Okay, in this video we're going to talk about question number 3 from the 2011 Form B AP Calculus AB free response questions. So in this question we have a graph provided where it says the functions f and g are given by f of x is equal to the square root of x and g of x is equal to 6 minus x. And let R be the region bounded by the x-axis and the graphs of f and g as shown in the figure above. So let's start with just part A here where it says find the area of R. Now we know that an integral gives us the area under a curve, so we need to use integrals here. The only thing that's maybe a tiny bit tricky here is that we've got two different curves put together, but that doesn't change anything. We just need to think about dividing this up right there where the two curves come together and then find the area under each part and then add it together, and we can do that. So let's move this over here a little bit and let's go ahead and integrate. So the area is going to equal, for part A, we have the integral from 0 to 4 of the square root of x dx plus the integral from 4 to 6 of 6 minus x dx. Again, that's just the definition of what a definite integral is. It's the area under that curve, or that's one definition anyway. And we go from 0 to 4 in the first one because we can see that my f of x intersects with the x-axis at 0, and then it intersects with g of x at 4, and then for the g of x part, it starts at 4 where it intersects with f, and then it intersects with the x-axis at 6. So those are sort of the boundaries of my curve. I don't need to worry about this 2 right here for the y coordinate just yet. We might need to worry about that later, but for right now everything's in terms of x, so we're just worrying about the x. So I integrate this, and for the first one I remember that I can treat the square root of x as x to the 1/2 and then just do the power rule for integration. So I have 2/3 x to the 3/2 evaluated from 0 to 4 plus, now for this next part I could absolutely do the power rule for integration again and get 6x minus 1/2 x squared, but I could also recognize that this is just a triangle here on the right side. This area is nothing more than a triangle with a height of 2 and a width of 2, so I do 1/2 base times height, and that's 2. So I'm just going to write that out so we remember where I got that from. 1/2 2 times 2. And when I plug in and evaluate here, we get 16/3 for this. When I plug in 4, and then obviously when I plug in 0, I get nothing, so it would be 16/3 minus 0. Plus, when I multiply this all out, 1/2 of 2 times 2 is just 2, and so I have 16/3 minus 0 plus 2, which gives me a total of 22/3. And that's part A. So now let's move on to part B. Now in part B, they say we want to find the region, the region R that we just found the area of is the base of some solid. And for each y, where y is in between 0 and 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose base lies in R and whose height is 2y. Write but do not evaluate an integral expression that gives the volume of the solid. So let's make this a little bit bigger because I want to draw a little bit about what they're talking about here. So we have to imagine here that we have something perpendicular to the y-axis. So we're going to be looking at something like this as being the base of my rectangle. And so I'm going to turn that into a rectangle over here. And I know that the height is going to be 2y, because they tell me that, but I need to figure out what this base is, how long that is. And I need to use the functions to do that. So I'm going to cut this up into a few different pieces. So we're going to continue working with this red, which is the actual base of this rectangle. I'm going to grab some other colors and talk about some other parts of the picture here. So let's start by just talking about how far it is from the end of my red line there back to the y-axis. Well, that distance from the y-axis over to the function, that's x. And I know that in this case, x is going to equal y squared. It's y squared because the function is y is equal to the square root of x. So if y is equal to the square root of x, then x is equal to y squared. Not too complicated. So that's that blue distance. That blue distance is equal to y squared. And again, we're trying to find this red distance here. So let's look at another distance that we know using g. And again, let me grab a new color here. Let's get a nice green. So I know that from all the way over here on g, all the way back to the y-axis, that's again x, but that's x defined by a different function. So this green length is going to be equal to x, but this time x equals 6 minus y. So if the green is 6 minus y, and that goes from way over here, all the way from way over here on the right, all the way back to the y-axis, and the blue, let me grab my blue again, is equal to y squared, and that's just from right here to right here. Well, the red then, which I've covered up now, let's draw that in again. The red should just be the difference between those two things. So this length here, which I called question mark before, that red length should be 6 minus y, the green, minus the blue, which is y squared. So that's not only that red there, but that whole thing is this base of my rectangle. So let's erase my question mark. That's kind of, no, it's not letting me erase. Oh well. I erased the 2, not the question mark. So 6 minus y squared. So that's the length of the base of my rectangle, and like we said before, we know that the height is 2y. So then the area of each rectangle is going to be 2y times 6 minus y squared. We want to find a volume, so we just imagine that each of these has an infinitely thin width of dx, and then I integrate to add all of them up. So my answer for part B should be the integral from 0 to 2 of the area of my rectangle, 2y times 6 minus y squared dy. And again, the dy is because I'm really imagining that this rectangle is a really, really thin rectangular prism here, and I'm drawing it way too thick here, but you know, if I draw it infinitely thin, you wouldn't be able to see it. And so this is really base times height times width to turn it into a volume. I'm going from 0 to 2 because now my rectangles are in terms of y. So it's because everything here is in terms of y that I need to use the y coordinate here for my interval from 0 to 2, instead of in part A where we went from 0 to 6, which was the length of the interval in terms of x. Okay. Now let's move on to, so in part C it says there is a point P on the graph of f, so just the left half of or the left part I should say, of the picture, at which the line tangent to the graph of f is perpendicular to the graph of G. Find the coordinates of point P. Well, in order to be perpendicular, I have to have the opposite reciprocal slope of G. So G always has a slope of 1, so let's write that down. Slope of G equals 1. And so we want our tangent line to have a slope of, so we'll say our perpendicular tangent line slope is then equal to -1. So we just need to find a place on f where the slope is -1. So I need to just set the derivative, which tells me the slope of the tangent line, equal to -1. So we'll start by looking at the derivative of f. So since f of x is equal to the square root of x, then f prime of x using my power rule, and again remembering that f of x can be written as x to the 1/2. Now it's the power rule for derivatives, so this would turn into 1 over 2 times the square root of x. And I need that to equal 1/2. I'm sorry, 1/2. I need that to equal -1. So -1 is equal to 1 over 2 root x. And I'm just solving for x because I want to know where is this point. I want to know the coordinates. So when I multiply this all out, I'm going to sort of cross multiply here, and we'll get -2 root x is equal to 1. So then the square root of x is equal to -1/2. Square both sides, and x is equal to, when I square -1/2, I get 1/4. So x is 1/4. I need the coordinates though. Find the coordinates. So I have to plug that into the original and get y. And since f of x is equal to the square root of x, well then f of 1/4 is equal to 1/2, and so my coordinates are 1/4, 1/2. And that's all I need. That is question 3 from the 2011 Part B form of the AP Calculus AB free response questions. Okay.